Good evening. So the topic that I am going to start with today is called as binomial theorem. Okay, so it is definitely related to what you have done in the past. Okay, but it is much more useful, it is much more efficient, and you have to assume something like you have to know what is NCR, what is the factorial, some things that you already know. You are going to use it in the current topic. Okay, so for example, I know what is n factorial, right? It's n into n minus 1 into n minus 2, right, until the number 1. Okay, similarly we know what is NCR. Okay, so it is n choose r, which means I have n things and I'm going to choose r things out of these n things. Okay, r things are to be chosen where the order is not important. Okay, this formula I hope you know, it's n factorial upon r factorial into n minus r factorial. Okay, it's not going to be every time that we are going to use NCR formula, but in some questions we will need this. Fine. So what is the binomial expansions or the binomial theorem? So you know how to expand a binomial of certain powers, right? For example, a plus b whole square, that is a square plus 2ab plus b square. Even for that matter, you know what is a plus b to the power of 1, isn't it? It is simply a plus b, only 2 terms. Okay, but when I go to a plus b whole cube, okay, now the expansion here is going to be a cube plus 3a square b plus 3ab square. Okay, so what I'm trying to say by writing all of these expansions, the point is, as you keep going up in the power, okay, the number of terms will also keep going up, right? So sometimes it is not possible to write all the terms in the expansion, okay, because I need not write, I do not need all the terms in the expansion for whatever the binomial that you are trying to expand. Okay, so whatever this is, a cube. Okay, so as you go higher and higher, it becomes more and more lengthy to write the entire expansion. Even though I may just need a particular term in the expansion, even then I'll have to write the entire expansion, correct? So that's where the binomial theorem comes in, okay, which says that any binomial expansion like this, okay, I can find a particular term in the expansion, whichever term I want to know. For example, this, just this, or maybe just this. Okay, I can simply use one formula and that will give me any term in the expansion I want, right? So if my expansion is like this, okay, so the general term in the expansion can be written as NCR a raised to n minus r into b raised to r, right? Now what is the meaning of this r? Okay, r is the number which starts with 0 and keeps increasing by 1 until it reaches n, right? Which means if I have a binomial of power n, okay, then the number of terms in the expansion is going to be n plus 1. Is that right? Okay, so with the help of this, I need not write all the terms. Okay, I can find a particular term in the expansion. So for example, if I have this a plus b raised to 5, which I wrote here, okay, if I want to find out the first term, okay, then r is going to be equal to 0. Simple. So n is nothing but the power, right? The power of the binomial. So here n is equal to 5, r is equal to 0. So to find out the very first term in this expansion, all I have to do is just write 5c0 and then a raised to the formula 5 minus 0 and b raised to 0. So this is your first term in the expansion, right? So like that, in the entire expansion, each and every term will be written in terms of this formula only, right? 5c1 a raised to 5 minus 1 b raised to 1 plus 5c2 a raised to 5 minus 2 and so on. Okay, so most of the times in the exam, they are not looking for many terms in the expansion. Okay, they will ask you a particular term. Okay, sometimes they might ask you the first 3 terms or the first 4 terms depending on the question. Okay, if they ask you the first 3 terms and 4 terms, then obviously I'll start writing like this. Okay, by putting in the values of r starting from 0 and just writing all the terms and simplifying it. Okay, but if I want a particular term, for example, I want in this expansion when the power of b is 3. Okay, in that case the first task would be identifying this is which term in the expansion. Okay, so I'll take that example. Before that, I'll just take a simple binomial which you can expand and write a few terms at least. Okay, so for example, we have here x plus 1 upon y, let's see. Okay, and I have power 5. So how will I write the first few terms at least? Okay, I'll try to write the first few terms. I know here that the n is equal to 0 and n is equal to 5 is the power, and r starts from 0 and goes until 5. Alright, I hope you're getting it till here so far. So to write the first term, I'm going to write 5c0 x raised to 5 minus 0, and this is 1 upon y entire thing raised to 0. Correct? Now the second term, 5c 1. Now r has to be 1. The x power will be now 5 minus 1. Correct? And the power of 1 by y, it's going to be r, right, which is one value, the number 1. Similarly, the third term, I'm going to write it like, okay, so this is how you simply apply the formula to get the first few terms of the expansion. Okay, so if I write it like 5c0, it's 5, then x raised to 5. 1 upon y raised to 0, it's just 1, so I'm not writing it. Okay, simply 1. Oh, sorry, this is just 1. Sorry, 5c0 is 1, not 5. 5c1, that is going to be 5. Okay, so x raised to what now? X raised to 4 into 1 upon y, and 5c2. If you put this in the calculator, this is going to be 15. Okay, so here I am supposed to write it 2, not a 3. So the power of x here is going to be 3, right, into 1 by y square. So like that, you can write all the terms in the expansion, which mostly they are not going to ask you to write all the terms. Okay, the use of this expansion is finding the particular term in the expansion. Okay, for example, if I take a question from here, so for example here, let's say there is a binomial here, 1 plus x upon 2 raised to 7. So suppose the question is find the term where the power of x, okay, power of x is 2. I want that, right? So the problem here is I know n, but I don't know r. That's the problem. Okay, so what should you do is write the general formula, which is 7c r 1 raised to 7 minus r and x by 2 raised to r. That's the general formula. Okay, so how will I identify the r? I know the power of x here is 2. Okay, so in this x will have a power of 2 only if r is equal to 2. Is that right? So all I have to do is just put the r value, which is 2, in this and calculate. That is it. Okay, I'll do x by 2 raised to 2. Okay, 7c2, 7 3s are 21 it is, into x square by 4. So you have found directly the term which is x having the power of 2. Okay, I did not have to write starting with nc1, nc0, nc1, all those terms and until I reach this point. Okay, but the power of x is 2. So that is the use of the binomial, right? So I'll take one more example. which is question number 3 here. Okay, just look at it. Here, this is the binomial and is equal to 12. So you have to understand what is the meaning of independent of x. Okay, what they are saying is, in this expansion there is going to be one term which is going to be independent, which means there is no x in the term. In other words, it means the same as the power of x is 0. Simple. Okay, so I'll first write the general term, which is 12cr x raised to 12 minus r into minus 2 by x square raised to r. So your focus is finding out the power of x in terms of r. Okay, you can ignore this part and the minus 2 ka power r, that we'll worry about later. How do I extract only the x terms out of it? Okay, and write a single power of x. So I know it is x raised to 12 minus r into 1 upon x raised to 2r. Okay, this is what happens. So if I simplify this, it's going to be x raised to 2 minus r minus 2r, 12 minus r. So this is nothing but x raised to 12 minus 3r. Alright, so 12 minus 3r is equal to 0 because I want a term independent of x. So this gives me r ka value as 4. The moment I get the value of r as 4, all I have to do is just substitute it here. Okay, and find out what the constant term I get. Alright, that is the question basically, to find out that particular r, because that particular r is going to give you the term which they want. Fine, so I'm going to substitute here. So I can write 12 minus 4 minus 2 x square. Okay, fine. If you simplify this, it's going to be 12c4. I'll put it in my calculator. Fine, 12c4 with so 4 and 12, it's 495. Okay, x raised to 8, 16 upon x raised to 8. So x terms get cancelled, and this multiplied by 16 is giving me 7920. So this is the term they are looking for, right? That's where the binomial is so helpful, right? This is like a very basic application. Okay, but in mathematics you also have infinite expansions of binomial. What are they? Okay, so sometimes what happens that your binomial has a power which is between minus 1 and 1. Okay, in that case what I do, right? So if you have a binomial like this and the power here is between these two, then the formula is pretty straightforward. Okay, so obviously it's of a particular type, like not every binomial will have a expansion, right? So generally it's 1 plus something or 1 minus something, okay, where a 1 is there, okay, and the formula will be given to you like this, right? Sometimes in the exam they'll give you a plus b types. Okay, so this has to be converted in the form of a 1 plus something or 1 minus something. So if you have something like this, okay, where I have 1 plus x, okay, and I have a power like this which is between these two, the formula goes like 1 plus nx, okay, plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 into n minus 2 upon 3 factorial 2x cube, and so on. It basically never ends. Okay, that's the idea. So not only if the here x, that there's a condition on x as well. Okay, not just not just the power. Okay, I have written the condition on power. Okay, so the condition on x is between 1 and -1. All right, and this power here, it may be a fraction, okay, or it may be a negative integer. Okay, so when you have a negative integer like this, okay, they have written -1, which means n belongs to positive integer, so the power basically is negative. Okay, in that case the formula applied is this. Okay, and this is the case where n is a fraction between -1 and 1. The formula is basically the same. Okay, so I'll take in a very simple example. Okay, so for example, if I write 1 plus 2x raised to half, now you can see they have written mod x, which is less than half, so it satisfies the condition, right? How? Because 2 of mod x, okay, 2 of mod x, can I say it's less than 1, right? It is within the range, within the condition, this term. So basically this 2x which is there here, it satisfies the condition, and the power here, even that is a fraction less than 1. So I can simply apply this formula and get my answer. Okay, so if I want to find 1 plus 2x, the entire thing raised to half, they want up to x cube, so I'll have to write the first 4 terms, nah? So 1 plus n, which is half, and the x term, which is 2x in this case, then half. Okay, and half minus 1. Okay, this is half minus 1, so I'll just write it half minus 1, and 2x whole square, correct, divided by 2 factorial plus half into half minus 1. So you'll have to write it properly, half minus 2 x cube upon 3 factorial. Okay, now we simplified 1 plus x plus, this is half into minus half into 4 on 2 factorial is 2, so I'm going to write x square plus half minus half, this is minus 3 by 2, right, x cube 3 factorial. Alright, or it's better I write 6. So I'm going to get 1 plus x, this is this 2, 4, this cancels out, I'm going to get minus x square by 2. Okay, then this is 8, 8 6 are 48, this 3 and 6, this will cancel out, 2, there are 4 2's now, है ना, 16 minus minus plus, so basically, and that's our expansion. Okay, so this is just like a basic introduction to the binomial expansions. Okay, so I have written here on a PDF file, okay, so that you can go through it. I'll send it on WhatsApp afterwards, right? So after every class I'll have these notes like this, so I send it to my students. So basically this is how the kind of questions that you can expect. Of course there will be a lot more complicated, but these are some basic questions which I wanted to explain for this topic. So hopefully you understood, and I'll see you next class. Thank you so much.